All right, so this is 2.1 limits, video number 2. Exercise 1, average speed during the first 3 seconds of fall. You should have gotten 48 feet per second. The answers to the odd numbered problems are in the back of the book, so you can check yourself. And I'm going to ask you to just come in and ask me questions. You'll have watched these videos before class. All right, moving on very quickly. So the average speed is one thing. Average speed just says between time 0 and time 2. We took the distance the rock fell, divided by the time it took to fall, and that gives us average speed. But of course, we know that that's not an accurate representation of what's happening at any given moment. The rock starts at speed 0 when we start, and it has some velocity at time 2, and this was just an average. So what we're talking about at any given instant is an instantaneous speed, or an instantaneous rate of change, also known as IROC. Average rate of change, by the way, AROC. Oops, OC. So, how do we find an instantaneous rate of change? Well, this is where the concept of limits comes in. What is the speed of the rock over a very small, what is the average rate of change over a very small time interval? So let's look at another example. If you're following along in your book, this is example 2 in section 2.1. And we want to find the speed of the rock. Rock, same problem at time 2. So what have we got? Well, we know that the average rate of change, the speed of the rock, is 16 over 2 plus some small interval squared minus 16 times 2, all divided by h. Okay? And if we do a little simplification, if we want to find the exact speed, h is equal to 0. Well, that doesn't help us because we would just get 0 divided by 0. Delta y over delta t is 0 divided by 0. So what we're going to do instead is let's do a little bit of simplification. We've got 16. I'm factoring out these two 16s. I've got 4 plus 4h plus h squared minus, whoops, I forgot to put a square there, 4, all divided by h. 4 minus 4 is 0. So this becomes, well, 16 times 4 is 64h plus 16h squared divided by h. But this is 64 plus 16h. And as long as h is not 0, these expressions are equivalent to each other. H is 0, of course, this isn't true because we had to divide by 0 in order to get there. So how do I find the speed at time 2? I take the limit as h goes to 0 of this function. I've run out of room. That h goes to 0 would be down there. Of running out of time, going to go fast. The limit as h goes to 0 of 64 plus 16h is 64 meters per second. Go ahead and do exercise 3.